US Physics Olympiad, year 2018. F equal MA, first round. This year, this Olympiad was split by two exams, A and B, and you can choose to participate either one day for exam A or next week in exam B. And the results was counted separately. That was again 25 problems, and for this amount it was given 75 minutes. Subscribe for this channel to get more problems every day. Problem 1. Which of the following graphs best shows the velocity versus time of an object originally moving upward in the presence of air friction? Problem 2. A 3 kg mass moving at 30 meters per second to the right collides elastically with a 2 kg mass traveling at 20 meters per second to the left. What is the speed of the center of mass of the system after collision? Problem number 3. Ball 1 traveling in the positive x direction strikes an equal mass ball 2 that is originally at rest. All of the following must be true after the collision except. Problem number 4. A satellite is following an elliptical orbit around the Earth. Its engines are capable of providing a one-time impulse of a fixed magnitude. In order to maximize the energy of the satellite, the impulse should be. Problem number 5. Two masses are attached with the pulleys by a massless rope on an inclined plane as shown. All surfaces are frictionless. If the masses are released from rest, then the inclined plane. Problem number 6. A packing crate with mass M equal 115 kg is a slide up a 5 meters long ramp which makes an angle of 20 degrees with respect to the horizontal by an applied force of 1000 newtons directed parallel to the ramp's incline. A frictional force of magnitude 400 newtons resists the motion. If the crate starts from rest, what is its speed at the top of the ramp? Problem number 7. A car has a maximum acceleration of a0 and a minimum acceleration of negative a0. The shortest possible time for the car to begin at rest, then arrive at rest at a point a distance d away is next one. Problem number 8. A disk of radius r small rolls uniformly without slipping around the inside of the fixed hoop of radius big R. If the period of the disk's motion around the hoop is t, what is the instantaneous speed of the point on the disk opposite to the point of contact? Problem number 9. A uniform stick of mass m is originally on a horizontal surface. One end is attached to a vertical rope, which pulls up with a constant tension force F, so that the center of the mass of the stick moves upward with acceleration a less than g. The normal force N of the ground on the other end of the stick shortly after the right end of the stick leaves the surface satisfies next conditions. Problem number 10. Which of the following graphs best shows the acceleration versus time of an object originally moving upward in the presence of air friction? Problem number 11. A light, uniform ideal spring is fixed at one end if a mass is attached to the other end, the system oscillates with the angular frequency omega. Now suppose the spring is fixed at the other end, then cut in half. The mass is attached between the two half springs. The new angular frequency of oscillations is next one. Problem number 12. A group of students wish to measure the acceleration of gravity with a simple pendulum. They take one length measurement of the pendulum to be L equal 1 meters plus minus 0.0 meters. They then measure the period of a single swing to be T equal 2.00 plus minus 0.10 seconds. Assume that all uncertainties are Gaussian. The computed acceleration of gravity from this experiment, illustrating the range of possible values, should be recorded as following. Problem number 13. A massless cable of diameter 2.54 centimeters, which is 1 inch, is tied horizontally between two trees 18 meters apart. A tightrope walker stands at the center of the cable, giving it a tension of 7,300 newtons. The cable stretches and makes an angle of 1.5 degrees with the horizontal. The Young's modulus is defined as the ratio of stress to strain, where stress is the force applied per unit area and the strain is the fractional change in length dl over L. The cable's Young's modulus is next one. Problem number 14. Three identical masses are connected with the identical rigid rods and pivoted at point A. If the lowest mass receives a small horizontal push to the left, it oscillates with period T1. If it instead receives a small push into the page, it oscillates with the period T2. The ratio T1 over T2 is next one. Problem number 15. A satellite is in a circular orbit about the Earth. Over a long period of time, the effects of air resistance decrease the satellite's total energy by 1 joule. The kinetic energy of the satellite. Problem number 16. A cylindrical space station produces artificial gravity by rotating with the angular frequency omega. Consider working in the reference frame rotating with the space station. In this frame, an astronaut is initially at rest, standing on the floor, facing in the direction that the space station is rotating. The astronaut jumps up vertically relative to the floor of the space station, with an initial speed less than that of the speed of the floor. Just after leaving the floor, the motion of the astronaut relative to the space station floor is next one. Problem number 17. A stream of sand is dropped out of a helicopter, initially moving at a constant speed v to the right. The helicopter suddenly turns and begins moving at constant speed v to the left. Neglecting air resistance on the sand, what is the shape of the stream of sand as viewed from the ground? The black dot represents the helicopter. Problem number 18. A mass m is attached to a thin rod of length L so that it can freely spin in a vertical circle with a period T. The difference in the tensions in the rod when the mass is at the top and the bottom of the circle is next one. Problem number 19. Raindrops with the number density of n drops per cubic meter and radius r0 hit the ground with a speed v0. The resulting pressure on the ground from the rain is p0. The number density is doubled, the drop radius is halved, and the speed is halved. The new pressure will be next one. Problem number 20. A spring stretched to double its unstretched length has a potential energy U0. If the spring is cut in half and each half spring is stretched to double its unstretched length, then the total potential energy stored in the two half springs will be next one. Problem number 21. A ping-pong ball, a hollow spherical shell with mass m, is placed on the ground with the initial velocity v0 and zero angular velocity at time t equals 0. The coefficient of friction between the ping-pong ball and the ground is mu s equal mu k equal mu. The time the ping-pong ball begins to roll without slipping is next one. Problem number 22. A small hole is punched into the bottom of a rectangular boat, allowing water to enter the boat. As the boat sinks into the water, which of the following graphs best shows how the rate water flows through the hole varies with time? Assume that the boat remains horizontal as it sinks. Problem number 23. The coefficients of static and kinetic friction between a ball and a ramp are mu s equal mu k equal mu. The ball is released from rest at the top of the ramp. Which of the following graphs best shows the rotational acceleration of the ball about its center of mass as a function of the angle of the ramp? Problem number 24. A mass is attached to one end of a rigid rod, while the other end of the rod is attached to a fixed horizontal axle. Initially, the mass hangs at the end of the rod and the rod is vertical. The mass is given an initial kinetic energy k. If k is very small, the mass behaves like a pendulum, performing small angle oscillations with a period t0. As k is increased, the period of the motion for the mass. Problem number 25. Alice and Bob are working on a lab report. Alice measures the period of a pendulum to be 1.013 plus minus 0.008 seconds, while Bob independently measured the period to be 0.997 plus minus 0.016 seconds. Alice and Bob can combine their measurements in several ways. First way, keep Alice's result and ignore Bob's result. Second way, average Alice and Bob's results. Third way, perform a weighted average of Alice's and Bob's results with Alice's results weighted 4 times more than Bob's result. How are the uncertainties of these results related?